All right, so in this assignment, we're going to be completing the chemical reactions. You always want to do that in this order. Predict the reaction type, predict the products, determine the subscripts, and then determine the coefficients. So we're going to be filling in the yellow boxes first with the products, and then at the end, we will balance the reaction with coefficients in the purple boxes. So to start off, we have Na plus O. This is a synthesis reaction. So these two elements are going to come together to make a compound. So when Na and O come together, we're going to have sodium oxide. What we need to make sure of in step 3 is that what our subscripts are going to be. So we need to check those charges. So sodium is +1, oxygen is -2. Those do not cancel each other out. So the formula for this is not NaO. It's going to be Na2O because those charges are going to crisscross. So once we've figured out our subscripts, we figure out our coefficients. So to balance this, we want to get the same amount of each element on both sides. I can see on the left I have 2 oxygens, and on the right I only have 1 oxygen. So I can multiply that by 2 so that my oxygens balance out. And then to get my sodiums to balance out, I now have 4 on the right. So I'm going to put a 4 in front of my sodium on the left to get that to balance out. Now that one is done. In our second one, we have MgO, just one single reactant, means this is going to be a decomposition reaction. So it's going to break up into Mg and O. Now, we don't have any new compounds, so we don't have to double check any charges or anything like that. But we do need to check, when we have single elements, we need to check for Brinkelhoff. Remember that we have those 7 elements: bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Anytime they're by themselves and not in a compound, they need a subscript of 2. Magnesium is not on that list, but oxygen is. So I'm going to give oxygen a subscript of 2. And now to balance my reaction, I need to give 2 of these to balance out my oxygen, and then 2 of these to balance out my magnesium. And you can see I have a balanced reaction now. My last one, I have CaCO3. Now this is another decomposition because we only have 1 reactant. It's going to break up into 2 products. But since it's CO3, that's a carbonate. Anytime we have a carbonate, a chlorate, or a hydroxide at the end, we're going to have to check our reference packet to figure out how it's going to break up. So check in your reference packet under the decomposition reactions, and you're going to see something that looks like this. So if we look at the carbonates option, we have MCO3. This is exactly what it says in your reference packet. Breaks down into MO plus CO2. So remember that M just stands for metal. So we're going to replace that M with whatever metal we have in our compound. In this one, it's calcium. So the M is going to be replaced with calcium. So I can replace that M with Ca. And that's going to show me what my products are going to be. It's going to be CaO plus CO2. Just like before, we formed a new compound now, CaO. So we need to make sure that that works out just like we did for sodium and oxygen. So down here, Ca has a charge of +2. Oxygen has a charge of -2. +2 -2 cancels out, so that's awesome. We don't have to add any subscripts. Our CO2 is already done for us, so all we have to do now is make sure it's balanced. And this one is actually already balanced. We have 1 calcium on the left, 1 calcium on the right, 1 carbon on the left, 1 carbon on the right, 3 oxygens on the left, and 1, 2, 3 oxygens on the right. So that is completely balanced, and we don't have to add any coefficients. You can technically put a 1 in those boxes if you want to, if it makes you happy, but that is not necessary. You can just leave them blank. So hopefully that helps you figure out how to balance these reactions.